Hey, Evan, welcome to the IoT For All Podcast. Thanks for being here this week.
Hey, thanks for having me, Ryan.
Absolutely. Let's kick this off with a quick introduction, if you don't mind, maybe a little background and who you are, as well as a little intro to the company as well.
Where do I start? I'm a native New Yorker who lived on the West Coast since I went to college, the University of Washington. Lived in Seattle for years, started my own startup, early stage, grew that quite big through the bubble, had to shrink it post the bubble, the first internet bubble, and then was able to sell that to SonicWall/Dell, ran a public company called iPass for 6 years, and then sat at a venture firm. Met Paul, the founder of Influx, when we were pre-revenue, and I joined when we were 20 people, and that's been a little over 8 years now.
So today's conversation, we have a really interesting topic that I think we've touched on briefly in the past, but never really dove into it in a way that I think our audience would benefit around time series data. A lot of our audience, I'm sure, is a little unfamiliar at times with what that topic means. So let's kick this off, if you wouldn't mind, talking about what time series data is for those who are unfamiliar, how it kind of fits into the IoT landscape.
At its most basic level, it's the process of collecting and reading time-stamped information. So information that is indexed, ported, captured by what time something happened. And if you look at that's a huge set of data out there. And its relevance broadly is about telemetry. The whole process of human design systems overall is collecting telemetry, reading out the telemetry, iterating on it to improving the system's operation capability. And you go on a journey of autonomy over time. And timestamp data or this kind of telemetry data is critical. And where it relates to IoT is sensors speak time series. That's the language that they speak. Pressure, volume, humidity, light, whatever the measurement is, it's spoken within a timestamp measurement. What happened, what happened, what happened, what happened, what happened. So time series are just pretty foundational. It's been around for a long time. If you were doing this 25 years ago, you used an Oracle database or an Informix database. If you're doing it 10 years ago, you might have used MySQL or a Cassandra. If you're doing it now, you're using this whole category of emergent databases. We're really specialized on time series. And as it relates to IoT specifically, there is a class of databases that, would not necessarily describe themselves as databases, but industrial historians that have been built into IoT systems, particularly industrial IoT, for a long period of time. So there's a long history here. What's relevant now is just how important that data is now and the ability to collect it and the specialized databases that are emerging to handle it. IoT is about connecting to things, sensors, usually physical things, but it doesn't have to be physical things, but usually physical things. And so IoT is about the instrumentation and operation of the real world. And in the world that we're currently transfixed on LLMs, which is instrumentation operation of the digital world, IoT is about instrumentation operation of the physical world. And so in order to instrument, operate, learn more, evolve the physical world, you need to collect all the data about what's happening all the time. And that data it can be very simple. It can be what was the pressure at time A and what's the pressure at time B. But it can be incredibly complex is what was the pressure, what was the light, what was the humidity, what was the position of the sun, what was the weather pattern, right? What are the barometer readings? It can be a really rich set of data around a timestamp that describes the real world. The richer the description, the more valuable your picture of the real world is. And IoT is fundamentally that.
What are some of the unique characteristics of time series data in IoT, and why is managing it oftentimes present, a challenge?
It's a very unique data type. One is because of how it's collected. Everything's got a timestamp data, which makes, if you can optimize around that, you get some benefits. Usually, IoT, if you can imagine a broad-based system, whether it's a self-driving car or an energy system, could have thousands to millions of sensors collecting around the world. Your ingest levels are through the roof compared to most data types. And if you're connecting, our base resolution is nanosecond resolution, and some customers actually use that. So you can start thinking about the ingest level associated with nanosecond resolution with hundreds of thousands or millions of sensors. You start talking about, billions of points per second coming in. So the ingest is high. Two is you're often summarizing that data because you don't need to keep high resolution data around long periods of time. You're often summarizing it. So you're often downsampling and transforming it. And so knowing that if you build a database that's oriented towards doing that you're in a better position. Third is, as part of downsampling or changing, you're evicting data quite fast. Most databases don't really aren't very good at evicting data. It's really a side process. It eats a lot of CPU. But time series databases have to be excellent at it because you're evicting data. Sometimes if your retention's short, almost as fast as you're collecting it. And so you can imagine this kind of small factory of data going at a different speed and pace because it knows what it's actually collecting and how it's working with. And then last thing about time series data is cardinality. Cardinality is a description of the number of measurements or tags or fields associated with each timestamp. And cardinality can be explosive. So if you have highly descriptive data on a timestamp, databases get choked by cardinality. They start not performing. They start failing. They start failing unpleasantly. And so time series databases have to be designed to handle cardinality. Those are probably three or four things that are different about that.
How do you all focus on kind of addressing those challenges that you just mentioned?
One is you build it into the open source and the actual database. These capabilities, you build it in, you optimize it for it, and so our latest versions, which will probably be out by the time you post this our discussion, has unlimited cardinality. It has super fast response time. What we as a time series database, what Influx has to be great at, have to be great at three things. That's our focus. This is our attention. We have to be amazing at ingestion. We just have to be able to pull that data in, and we has to be able to be read right away. It can't be we're ingesting and then you can read it in 5 seconds. It has to be ingested and read immediately. Because if you're going to build an operational system around this data, you have to be able to read them in. So one is we have to be able to ingest and read immediately. Two is we have to be able to organize that data so it can be handled and managed appropriately. So you can imagine the amount of data. So some of it should go to object storage, some of it should stay on disk, some of it should go in memory, some of it should be indexed. So it'd be super great at you take it in, you organize it, so it can be. And the third, maybe even the most important, is we have to be able to query. In some cases, below 10 milliseconds for last values, below 50 milliseconds, below 100 milliseconds for longer things, 1 second. Because the idea is you're building an operational platform that is not only collecting the telemetry, but then is acting on it. And acting on it is a function of the queries. So if you query, what's the state of this system at this point? Let's act. That query has to be super fast. One example I could give you is, we power Tesla Powerwalls. I have an app on my phone. I can update that app every second, and it'll tell me how much power is being generated by my house and going to my Powerwall. Right? Those kind of queries have to happen very fast in order for that app to run correctly.
Absolutely. Yeah, and I'm sure there's people out there listening that struggle with managing time series data. If you were to give them maybe one piece of advice on kind of what's that maybe that first step they should take on reevaluating their approach, is there something that comes to mind?
It's about architecture and design. And so, my most people they're comfortable with Postgres, or they're comfortable with Mongo, or they're comfortable with some gem. And so they build the thing they want, and it's kind of operational and it works for them. But as the system scales, this is where we get most of our customers. They begin to say, wow, we're starting to run into either cardinality, performance, query performance limits. We need to look at it. It's not just us, but other time series vendors do a reasonable job, and they start to look at time series specific stuff. If I'm sitting talking to a group of, let's say IoT, industrial IoT, or energy IoT people, I'm saying start your process with a time series database. Right? It'll perform well at low volumes, but you'll start to see the real benefits as you start to really engage and mechanize your system. And so that'd be my primary advice. And there are ways you can run it in the cloud, you can run it on prem, you can run it at the edge.
Are there leading applications in IoT that you're seeing rely on time series data, or is it basically across every type of application use case? Like, which ones are the most compelling to you?
So we think of it as primary operational applications. And this is actually important discussion because it bridges into the role between operational time series and AI. When you build a system, let's use a sort of an a standard IoT system, maybe a self-driving car. When you build that system, right, what you're trying to do is you're trying to go on a journey of intelligence, right? You're trying to say, I've instrumented the car with, I'm making up a number here, 1,000 sensors. I'm running it on the road for a week. I'm collecting all that data. I'm looking at it. I'm evaluating it. And then I'm correcting specific design capabilities of the car to reflect on that data. If I do that little loop a billion times, I might have a fully self-driving car handling all the situations that the car can encounter, all of that sort of stuff. What was the sun? What was the angle of the sun? What was the temperature of the road? What was the tire inflated? All that sort of stuff. I can run that loop and I get an increasingly intelligent and increasingly autonomous system, which is what all human design systems want to be. The same is true of a factory floor where I'm manufacturing something. I keep perfecting using that telemetry data. Eventually, I want the system to self-perfect. The role of time series is lots of where the self-perfecting comes in is getting automated by AI. And so I'm taking this time series data and I'm building training models based on it, right? I'm building real world training models, whether it's robotics or self driving cars. And I'm typically doing that in kind of a lakehouse environment, in a deeply where I can take structured, unstructured data, I can put it together with the time series data. And I can basically build a model about how I think the world's going to work. But then I have to operationalize all that. And so the operation isn't just the collection of the telemetry, it's the actual taking. So I build these inferences and then I have to implement them. So when the car sees X, how quickly can it respond to X? Right? When the factory floor sees some condition out of sync, how quickly can the factory floor adjust? That's where the operational database, the time series database comes in because it's going to query in real time. It's going to have the inference information from the model. It's going to query in real time. It's going to take action. That's the automation that we're looking at. Most of what happens in time series today is people looking at dashboards or triggers. That's about to change, right? That's going to change because these systems are going to be self-driving. They're going to be growing in intelligence. And so the operational time series is separated from the analytical training and model stuff.
No, absolutely. And that kind of alludes to my next question, which you've already kind of hit on some, which I'm sure would be the answer here when, especially when talking about AI. With the exponential growth of sensor data that we're seeing as more applications get out into the world, are there other trends that you're seeing in how companies will collect, store, and analyze time series data just in general?
I think that the most important trend is the relationship between the model building, the machine learning, and the organic time series data. That's becoming, most everybody we talk to, all of our customers have figured out these architectures that are breaking out the operational data from the analytical data that drives the models and trying to figure out ways to integrate them. Most people are relatively early in their journey of integrating that. But the biggest trend is we see that requirement is emergent. Before, if we were talking 3 or 4 years ago, the primary requirement is let's monitor this system and report. But now we're seeing like, okay, we can actually begin to move steps towards autonomy, which is, and so that's I think the most important trend. But obviously we're seeing that in the digital world too, in the form of LLMs. We're seeing it all over. But where it hits the real world is that. And then because you've been covering this a while, is we're not getting less sensors. We're getting cheaper and more sensors, and we're sensorifying the physical world at an incredibly rapid pace.
Are there any additional challenges that you foresee coming out of the fact that we're going to have more sensors and we're going to have more data being collected from the physical world as we kind of look out into the future?
My techno optimism, I'm sure there are externalities that will be problematic. But overall, that ability to monitor the physical world more effectively, whether it's healthcare, whether it's climate, whether it's space, that's a very powerful and important thing. And I think there are probably going to be some negative externalities, but most of what I see is really positive. Particularly where we talked earlier before we got on about Southern California and the fires and climate changes. The ability to monitor the physical world is going to be really, really important.
Tell me a little bit about kind of your all's future outlook with what role will InfluxDB play in addressing kind of these challenges that we're talking about on here?
I want to be humble facing it. We are a data platform, but all things start with data. So, our mission is to be excellent at those three things I mentioned before: the ingest, the organization, the querying of that data so it's available. If AI and machine learning and the increasing, world of autonomous systems is happening, then we're the picks and shovels of that. If AI is the refinery of all the information, then we're pulling the oil and gas out of the ground. Whatever it is, we're providing the raw material to manufacture that intelligence, and then we're providing the ability to act on it. That's kind of how we organize the world. So we built, this next version of the product is built with those things in mind. It's deeply integrated with lakehouse environments.
Data has always been talked about as how important that is in our daily life and every business's life. But as we start to really pull more and more data from the physical world and AI grows in its capabilities and functions and to solve business problems, a company like yours is helping make that easier. And I think being able to do that's a very big role in the future of where we're going. And I think that's an important thing to highlight. Where can our listeners learn more about what you all have going on, what you're doing, what applications you support, get in touch, follow up, all that kind of good stuff?
It's the classic. It's at InfluxData.com. There's also a bunch of GitHub repos. We have huge contributions to the open source, Apache, Data Fusion, Flight, SQL, all that sort of stuff. There's our site. There's blog posts. It's all the stuff you'd expect.
Well, this has been a great conversation, Evan. I really appreciate your time. What I'd love to do is obviously we'll get this out, but probably have you back later on this year just to kind of talk about the growth of the space and what's happening as AI grows, as IoT grows. Just more data out there. I would love to kind of keep understanding what your all's take is from your perspective.
100%. I really enjoyed, Ryan. First of all, it's great to meet you, and I really enjoyed the conversation. And congrats on your success.
Thank you. Yeah, we've been having a good time doing it, and hopefully our audience keeps finding value. And obviously, the more experts like you we can spotlight, the more value hopefully you can provide. So thanks again for your time.
All right, man. Take care.